Fabulous. Jonas.
Yeah. Hi, I'm Jonas. I'm a master student at University of Heidelberg, and sorry, a master student at the University of Heidelberg, and I'm working on Fabulous, and I show you like a sneak preview of Fabulous 2.0. I brought a demo of the first chip we made with the Google shuttle program. I think it was MPW2 or 3. This is a FPGA chip we made, and you can see all the images that you can see are stored in block RAM, and the readout electronics are all implemented in our FPGA. And yeah, this is run fully on open source. I will just place it here, and you can see it just works. So Leo also already introduced us a bit. What is Fabulous? Yeah, it's a fully open source eFPGA framework. Comes with batteries included, more on this later. It's relatively easy to use, fully customizable down to every bit and piece you want to customize, and the quality of results are pretty good. Here's a comparison that Leo did, for example, for his Greyhound chip, comparing two designs, the Curve, the bigger version of the Surf Core, and Phasey RISC-V on a Fabulous chip, comparison to a Lattice ICE40. You can see it's how many LUTs are used. It's pretty much, yeah, it gets in a similar direction, and yeah, and as you see, we are silicon proven. We have tape outs on the major open source PDKs, and also on a lot of commercial PDKs down to 28 nanometers. 22 nanometers is currently in the making, and yeah. So the batteries I already talked about. Yeah, we have a tile library. Leo told a little bit about this. We have standard CLB tiles with 8 LUT4s, register files, multiply accumulate tiles, IOs, and a little bit more. We integrate the cut tools, Jonas and NextPNR for the user design flow. You can use Verilog and VHDL for fabric generation, and also for user design flows, thanks to Jonas' GHDL plugin. We shipped with a simulation setup. We have a Fabulator GUI to visualize the fabric and also the user design on it. The fabric supports partial reconfiguration. This currently is work in progress to automate to use, but the fabric supports it. So this is a tooling issue, but not a fabric issue. We have a lot of documentation, and just scroll through at some point, and there are a lot of more features. Yeah. So the general design flow of fabric, it's basically 3 parts. First, you do your a few config files, tweak around, or you can just shuffle around some of our basic tiles. We have a primitive library that's already in Jonas included. And then you say, okay, Fabulous, do the generate the fabric. It spits out RTL that you can throw in your backend flow, either LibreLane or, of course, Cadence, Synopsys, whatever. You do your fabric, and afterwards you tape out your chip, you get it back, and then you have a user design flow that utilizes Jonas and NextPNR. We're generating the models on the fly for NextPNR, and that you can directly use it to generate your bit stream that you can throw on your chip, like here. For version 2, we have a direct LibreLane integration we're working on, that you have like one click from your fabric description down to GDS with an optimized and tiled fabric. There are a lot of optimization games you can play with implementing FPGAs, and we try to implement all of them already in one flow. For the open source PDKs and for commercial PDKs, we have working on some constraint guide, how to do it yourself. Timing model generation, that was Leo already talking about. To automate this directly out of the the output of your ASIC flow, that you extract the timing and have the timing model for next PNR. Then we added like custom tile generation. The beauty of NextPNR, of Fabulous, sorry, was always, okay, you can fully tweak it, that you can throw in custom primitives. We now automated this, that you can just throw in some RTL and we generate a tile for you, and also I/O generation, that you can generate custom I/Os. A lot of small improvements. We made a Python package that it will be soon on PyPy whenever we do the release. Joseph-based primitive parsing, throw out our own manual parser, utilize Joseph, automate dependency management, settings manual. It's like a lot of small stuff that happens that made Fabulous a real, let's say, software project from a more or less before academic project. And we worked on having a really good baseline to accelerate the development in the future, a lot of testing, automate testing, CI, and so on. And yeah, let's show a quick demo. So I've already installed Fabulous here. For generating a demo project, we just say, okay, Fabulous create project, and then we run the Fabulous shell. We also have like script support to automate this. This reads in all the config files that we have. Previously, we have like a simple CSV config files. I can show this. For example, I prepared this. No, sorry. Oh, this doesn't work in the shell. Anyway. I'm confused. Something fucked up my setup, but it's not that bad. I can't show the config files currently, but these are simple CSV files where you can shuffle around tiles and do your own floor planning. And if you have done this, it's really easy to do. And you after that, you can just say, okay, run Fabulous Fabric, which generates all the RTL files and everything you need that you can just throw in the backend flow, and also the NextPNR model. We have run Fabulous bitstream, and there we have like we provide a user design which is like a simple counter. This now called Joseph's NXPNR and generated the bitstream, and we can say run simulation with the sorry. This is always the trouble with like live demos. Sorry, I forgot. Okay, you have to say, okay, I want the FST output first, and then it has also tab completion. I was confused why it was not working. You just say, okay, this is the bitstream I generated, and our simulation setup now simulates the whole fabric that was generated previously, and pumps in the bitstream that we generated before, and also runs the same bitstream in parallel, or not the bitstream, the implementation in parallel, and compares the outputs against each other. So it's just a counter, and it says one time it's run on the bitstream and one time not. And yeah, we have also the fabulated GUI I talked about previously, which just shows like our fabric, how it's implemented, all the routing, and you can load your FASM, of the bit stream, and you can see already here how it's routed. So these are LUT tiles, these are the primitives of the LUTs, and you can see how everything is routed and works together. It can also show the primitives and a lot of other stuff. Feel free to explore. Back to the presentation. Also, in Heidelberg, we do every year a summer school with like a tape out, a hackathon and tape out at the end. This year, we use like something like tiny tape out tiles where users created their own tiles, and we connected all of them with a fabulous fabric. These are our sponsors, and we are inviting new sponsors for next year. So our participants, feel free to contact. And yeah, here you can find like all the QR codes for the development branch, documentation, our other projects, and some of the tape outs we made. We have a lot more, and yeah, that's it. Thanks.
Questions?
Hi, great talk. I love this stuff. So, can you talk a little bit about the kind of the P&R layout? So presumably there's like a regular structure that is almost manually done, perhaps, and then tiled. Is that the case for the physical design?
You mean for the ASIC implementation?
Yeah.
That's a view of the optimization games you can play. Usually you have like really regular structure in FPGA, so all the CLB tiles are basically the same. So you implemented them, they implement them as hard macros with fixed pin placement that you can just directly stitch them together, and with no gaps in between, so you get like a really high density, and also the cool thing, constant timing through the fabric. And we have automated this in LibreLane. There are still a few things to tweak, but this will be like a one-click solution.
Or just LibreLane? Vendor tools as well? Or?
What? For commercial tools, we have like constraint guides, or we are working on constraint guides how to do this, since of course we can't give you our scripts. But if you want to do something, feel free to reach out. We try to help however we can. Yeah.
Leo mentioned that in the previous talk that his design was a single clock domain. Is there support for multiple kind of global clock trees?
Currently, we have only single clock domains supported, but this is planned for future releases, not for the 2.0. 2.0 was more like, okay, getting the baseline done that we can accelerate this kind of development better in the future.
Yeah. And what additional tiles do you think would be useful? Like, what are you planning on adding in?
I mean, for the tiles itself, we automated pretty much the progress of having throwing in additional tiles. So if you say, okay, you have something really to accelerate, would accelerate the stuff I want to do on my fabric later, you can basically define a primitive. It has like a few constraints, but you can define a Verilog file and say, okay, generate a custom tile, and it generates everything with the routing and connects the stuff, and that's basically done for you.
Yes.
You showed some QOR numbers at the start, which is basically LUT counts for a given design, and showed it was competitive to ladders. But is the actual LUT itself competitive? I mean, are you? Yeah,
the LUT itself is pretty much similar. This comes from the initial implementation of Fabulous. The LUT implementation was pretty similar to that what Lattice has, since the open source support is pretty good. I mean, the support in JOSIS and XP and everything is really good for this. So
so you think that's a like for like comparison? That's a
what?
That comparison is like a like for like. Those LUTs have the same.
Yeah, depth. We have like each CLB has 8 LUT4s, so this is pretty much similar to what Lattice offers. We have like an additional multiplexer behind these to build like fractable LUTs out of this, which is currently not utilized in JOSIS, so this needs some more tech mapping stuff. But from the general LUT structure, it's pretty similar to what lattice offers.
Okay, I have many more questions, but we could talk later.
Yeah, sure. Feel free.
Thank you very much, Jonas.